Quite frankly, the NCEA 2 algebra was a little tough. I want Captain Calculus to make algebra great again. Let's see how he goes with the calculus exam. Calculus 2 is a great, great subject, frankly.
So now we begin to loop around back to calculus. This is level 2 statistics, mathematics and statistics. It is applied calculus methods solving problems at level 2. So this is NCEA Level 2. It's kind of equivalent to International Baccalaureate SL level and kind of lower GCSE. A little bit of the GCSE, maybe a little bit below GCSE level if you're in the UK. So I'm just going to be using the formulae that are given to you. So this is taken directly from the formula sheet that is given to students and also the calculator that most students use. All right, first thing up is going to be question 1, logically speaking. Tends to come first. So a function is given by f of x is 2x cubed minus 3x squared plus x over 2 plus 7, and find the gradient where x is negative a half. Okay, so f of x is that, then f prime of that is going to be 3 times 3 is 6 x squared minus 6x plus a half. Remember that x over 2 is the same as half x, and the 7 goes away. So what do we do then? We substitute in negative 0.5. So it's going to be 6 times negative 0.5 squared minus 6 times negative 0.5 plus 0.5. I'm just going to put these as decimals. Now, I just want to go over an interesting thing here. If we have negative 0.5 and we square it in the case of your calculator, it gives us this answer, negative 0.25. And it's not correct. If, though, we put it in calculator, let's make it a negative number. If we put it in the calculator and put it in brackets, we get a different number. It's a glitch on the Casio calculators. I think the later ones, this glitch is fixed, but you should know that a negative number times a negative number is going to be a positive number. So this is wrong, this is right. Okay, so saying that, let's get back to it. So this is going to be 0.25. So 6 times 0.25 is 1.5. And minus 6 times minus 0.5 is positive 3. And positive plus 5. And so 1.5 is 2 plus 3 is 5. So it's our answer there. But yeah, just be aware of these Casio calculators, the old ones in particular. Test them out if you're not sure. Right, next question. We've got the cubic function minus x cubed over 3 plus 2x squared minus 3x plus 6. Find the equation of the tangent to the curve at x equals 2. So what are we actually going to get? We're going to get a tangent as a straight line, so it's going to be in the form mx plus c, and it's going to have the same gradient at x equals 2. So it's going to become looking like that. It's going to just touch it and then move on. So first thing we're going to do is we need to work out what the other coordinate is when x equals 2. So we need to find f of 2, don't we? So it's going to be minus 2 cubed over 3 plus 2 times 2 squared times 3 times 2 plus 6. So this is going to be, so 2 cubed is 8, so minus 8 over 3 plus 8 minus 6 plus 6. Well, that's good, they're going to cancel. So here we have minus 8 over 3 plus 8, and that's a bit messy. So what I'm going to do, I'm going to get this 8 over 1. I'm going to multiply it by 3 over 3, which is 1. 3 over 3 is 1. So it's going to be 24 over 3. And I'm going to get it as a common denominator. And that means that we can rewrite that as 16 over 3. So it's going to go through the point 2 comma 16 over 3. So now what we need to do is we need to find the gradient of x equals 2. All right, so what I've done is I've copied it, the original function down here, so we can use it as base. So I'm going to differentiate this. So f prime of x is going to be 3 times negative x over 3, which is 3 over 3. So it's going to be negative x squared plus 4x minus 3. And I'm going to put in 2 in this case. So minus 2 squared plus 4 times 2 minus 3. So that's going to be minus 4 plus 8 minus 3, and that's going to be equal to 1. So the gradient is 1. So now we can use our equation y minus y1 equals mx minus x1, where that's y1 and that's x1. So y minus 16 over 3 is going to be equal to 1 x minus 2. So y is going to be equal to x minus 2 plus 16 over 3. And so minus 2 plus 16 over 3. I'd recommend when you use the fractions like this, put brackets in this case your calculator, but a bit nippy about that. So it's 10 over 3. So our final equation is x plus 10 over 3. That's our final answer. So we will circle that, highlight that for us. Right, steaming right along. So we're given the gradient function f prime of x here, 2x squared plus 2x minus 24. One thing I'd say is don't try to simplify it just yet, just keep it as it is. If you're going to integrate or differentiate, keep it as it is. I know you can divide them all by 2, but we're not going to do that just yet. Okay, find the original equation f of x, given that the y value at the local minimum is minus 46. So, how are we going to do this? So we're going to need to find what the minimum maximum is. So that equals 0. And now, because we're not differentiating it, we're just solving it for x, we can divide both sides by 2. So 0 divided by 2 is still 0. So x squared plus x minus 12 equals 0. So I want two numbers that multiply give us negative 12 and add to give us positive 1. And it's going to be positive 4 and negative 3. So x plus 4, x negative 3 equals 0. Now, which one of these is the maximum? Well, let's do this one first. So x minus 3 is 0, so therefore x equals 3 is whether it's a minimum or a maximum. So we want to differentiate the original equation. So we need to go back to this form here just to be on the safe side. So if the original differential equation is this, okay, if we differentiate that again, we're going to get 4x plus 2. And if we put in 3 in here, it's going to be 4 times 3, which is 12, plus 2, which is a number greater than 0. So that's the minima. The minima is when x equals 3, and we know it's at minus 46. So there's a minima at 3, comma, minus 46. Okay, we're almost there. We've done most of the calculus now. We've done differentiating. Now we need to get from the prime function to the original f of x. So let's put the original thing we're given here. We want to find f of x, so we're going to need to integrate. So f of x without a prime is going to be 2x, and the power gains 1, and we divide by that power, plus 2x, it gains a power, and we divide by that power, minus 24x plus c. So now we're trying to find c, but we know what when we put in 3 x, when x equals 3, y equals negative 46. We know that point. So therefore, 2 times 3 cubed over 3 plus 2 times 3 squared over 2. I guess that's kind of redundant there. Minus 24 times 3 plus c equals negative 46. Well, 3 there like that, so it's going to be 2 times 9, so it's going to be 18 plus 9 minus 24 times 3. What that is off the top of my head. 24 times 3, 72 plus c equals negative 46. And now we're just going to grab our calculator. So clear this. So negative 46 minus 18 minus 9 plus 72 is, drum roll, negative 1. All of that for negative 1. So c equals negative 1. So our final equation is going to look like this. So f of x is going to be 2x cubed over 3, and these 2's here are going to cancel, plus x squared minus 24x, and now we know what c is, minus 1. Did they want us to solve anything? No, they just say that the minimum is there. Okay, so that's all of question 1. So moving on to question 2, you will get these in the exam to use it. Very, very common. So we're given f of x, the original equation, so this is f of x, and on this set of x's here, we want to draw what it would look like if we differentiated it. So from here, I guess, to infinity to here, it's negatively sloped. So it's going to be below the curve until we get to this point here. Right, the dotted line. So it's going to cross the x-axis there. And then it's going to be above, positively sloped between here and here. So it's going to be above, and then at 0, it becomes flat again. So the slope is 0. And then it's going to be negatively sloped from here to here. So if we go down a bit, it's going to cross the x-axis again. And then everywhere across from there, it's going to be positive. So here it's going to be negative, positive, positive, less positive, and then up again. So the rule of thumb is that when we differentiate, we lose a hump. So here there's 3 humps or stationary points. 1, 2, 3. Here there's only 1. There's only 2. 1, 2. That's how we do those. So here's another one where they give us the prime equation. So it's been differentiated, and we get this thing here. And then we're told that the original equation, f of x, goes through this point here. So you should read this in the original equation when x equals 2, y equals 5. Or in other words, f2 equals 5. Okay, so to get from here to here, we need to integrate. So the original function that we're given here, the differential function, is this. Let's integrate it. So the 2x stays there, it gets a power, we have to divide that by that power. The negative 6x stays there, we gain a power, and we have to divide by that power. The 2x stays there, we gain a power, we have to divide by that power. The 4 stays there, we get an x, divide by 1, I guess, as well, but we also need to add the c. So all of the hard work is now going to be in the form of the c. But I'm going to just simplify this a little bit. So this is the same as x to the power of 4 over 2. The 2 and the 4's cancel. Negative 6 over 3 is negative 2x cubed. 2 over 2 is 1 plus 4x plus c. Okay. Yes, all good. So now what I'm going to do is I'm going to put in 2 where we have an x. So 2 to the power of 4 over 2. This is going to be the same as power of 3 minus 2 times 2 cubed plus 2 squared plus 4 times 2 plus c, and that's going to be equal to 5. So let's move this down a bit. So 2 cubed is 8 times, whoops, no, 2 cubed, it's a 2 apparently. So yeah, again, cancel, going to go 3, yes. So this is going to be 8 minus 2 times 8 is 16 plus 4 plus 8 plus c equals 5. Now we're on the right track. So all those 2's floating around going into negative. So we've got clear 5 minus 8 plus 16 minus 4 minus 8. That's going to give us c, and c is 1. So c is 1. Now we know the original equation. So f of x is going to be x to the power of 4 over 2 minus 2x cubed plus x squared plus 4x plus 1. You know what the c is now. And that's how that's done. All right, the next one is pharmacokinetics. It's calculus applied to how chemicals react with your body. It's really important if you want to do pharmacy to do this for obvious reasons. So Hemi is part of a student research project on how caffeine enters the bloodstream. A new device measures caffeine levels in the blood. Is monitored for 180 minutes. So that's obviously going to be a T. 3 hours, so 180 minutes. At some point, he's given a cup of coffee to drink. Okay, his caffeine levels can be modeled using this equation. Seems weirdly specific, but okay, let's go with it. Where C is the concentration, and that's an interesting one, micrograms per litre, and T is time in minutes. Okay, show that the rate of change of the concentration is minus 16 micrograms per litre per minute. It's an interesting unit. After he's been there for 60 minutes. So when T is 60, find the change in concentration. So C of T is that. C prime of T is going to be T squared over 3. So we're going to need to simplify this a bit more. Minus 2.8, 2 times 1.4 is 2.8. So 0 plus 80, and I'm just going to copy these out. So 50. So T squared over 50 minus 2.8 T plus 80. Yeah, that makes sense. Yes. Now we want to put in 60 in there and see what we get. So 60 squared, I have no idea what that is, minus 2.8 times 60 plus 80, and hopefully it's going to come to minus 16. So 60 squared, 3,600. Yes. Divide that by 50 is that minus 2.8 times 60 is that plus 80, which is here, and the answer is minus 16. Minus 16 in this funky unit. Micrograms per litre per minute. Oh, okay, that makes sense. Change in the amount. So this is going to be a mass over a volume over time. Okay, interesting. But wait, there's more. Use calculus to justify when Henry was given the copy, assuming the caffeine enters the bloodstream as soon as it is consumed, necessarily true, and continues to increase for some time after consumption. So that's not true, but let's make out that it is true. So what I've done, I've taken the graph of the amount of concentration in his bloodstream. I'll just show you what it looks like. Go to draw. So here's where we start. So he starts with like 240 micrograms per litre in his blood, and then it goes up, and then it hits a peak there, I guess, at some point, and then it starts tapering off, and then all of a sudden, hey presto, here There's a minimum point and it shoots up. So we need to know what this one is. All right, but we need to use it. We need to use calculus to do it. So we're going to take the difference equation. I'm going to rewrite it slightly. You'll see why in a second. Minus 2.8 t plus 80, and we're going to set that equal to 0. We're going to presume that there's no other stimulus that's putting caffeine into his body, so the minimum point must be where it takes off. Okay, I don't know. I can't be bothered solving this, so I'm just going to use the calculator to solve it, which is perfectly okay. You've done all the calculus. And it's a polynomial solver, degree 2. So this is where that comes into play. Minus 2.8, 80, solve it, and we get 140. So t is at a peak or a minimum at 40 minutes and 100 minutes. So we know it's going to be the 100, but let's test it out. Can we prove that when t equals 100, it's a minimum? Well, we can. So let's differentiate this again. So the concentration, the change of the concentration is going to be 1 over 25, so 2 times 150, minus 2.8, sorry, t. If we put in 100, so yeah, it's going right. 1 over 25 times 100 minus 2.8. Is it going to be greater than or less than 0? So calculator comes to the rescue. So 1 over 25, 0.04 is that, yeah, times 100 is that, minus 2.8. So it's a positive number, so therefore it's a minimum. It's greater than 0, so therefore there's a minima at 100 minutes. And if we presume that there's no other caffeine source, then that must be when he gets his coffee fix. Good question, though. Good question. So the next question, I'm going to give myself a lot of room because I've got a feeling this is going to take lots of scribbling. So we're given function f of x is ax cubed plus bx squared plus ax, so the a's come back to what is again, plus 2, where a and b are constants, and the graph intersects the x-axis at x equals 1 and has a stationary point at x equals minus 1. So what does that tell us? It cuts the x-axis at x equals 1. So in other words, point 1, 0 is on the fx, on the original graph, and it has a minima point at where x equals -1. So it has a minima point or a maximum point, a stationary point at that point. It's going to get the saddle point, but we're going to discount that. Use calculus to find the coordinate of the other stationary point. Use calculus methods to determine what type of stationary point this point is. Okay, what we need to do therefore is find what A and B are. So let's put this information into the original equation, and then let's put this information into the derived equation. You'll see what I mean. So A times 1 cubed plus B times 1 squared plus A times 1 plus 2 equals 0. Okay, so 1 cubed is 1, so A, 1 squared is 1 plus B, 1 times A is A, and the 2 comes along for the right. So let's collect up terms. 2A plus B, and I'm going to bring this negative 2 across. Okay, so let me put that there and park that. Now what I'm going to do, I'm going to differentiate it and put this information in. Okay, so if the original equation is ax cubed plus bx squared plus ax plus 2, that's our original equation. Our first derivative is going to be 3ax squared plus 2bx plus a. And we know that that's when we put a negative 1, we get a 0. So wherever we have an x, we're going to put a negative 1, and we're going to set that equal to 0. So 3a negative 1 squared plus 2 times b times negative 1 plus a equals 0. So negative 1 squared is 1. So 3a minus 2b plus a equals 0. Now let's collect up the terms. So 3a plus a is 4a minus 2b is 0. And now we have two equations, and oh, sorry about that. My neighbour is cooking, and his idea of cooking seems to be no matter what he cooks, it entails banging of pans. Life in the city, eh? So what we have now is two equations and two unknowns. So we can now solve for A and B. When we solve for A and B, we've got everything we need. So 2a plus b equals negative 2. There's nothing I can really get rid of there. What I'm going to do, I'm going to multiply the whole thing by 2. So we have 4a plus 2b equals negative 4. And now I'm going to substitute the other one from here down to here. So you should know how to do this. So now I'm going to add one to the other. So 4a plus 4a is 8a. 2b minus 2b is no b's. Minus 4 plus 0 is minus 4. So a is going to be minus 4 over 8, which is minus half. So we're halfway there to finding our equations. Let's sub it into this equation here. So 2 times negative a half plus b equals negative 2. So 2 times negative a half is negative 1 plus b equals negative 2. So b must equal negative 1. And now we have everything we need to solve. We know that a is negative half and b is negative 1. So I'm just going to copy this down, and then we're going to get to solving it. Okay, so what I've done now is substituted in the values for a and b. And now I'm going to go ahead and differentiate it. Use my neighbour again. Minus 3 over 2 x squared minus 2x minus a half. And I'm going to set that equal to 0 and solve. So that's kind of messy, so I'm going to use the calculator again. Again, I've done all the calculus, so I can jump on the calculator. I don't really want to be factorizing minus 3 over 2. polynomial solver, degree 2, and this is minus 1.5 minus 3 over 2, minus 2, minus 0.5, and we get minus 1 over 3 and minus 1. So there's a minimal maxima at x equals negative 1 and x equals negative 1 over 3. Now, we know, therefore, the x coordinates. Now we're going to come along to the original equation and we're going to put 1 over 3 in there. Okay, so, yeah, there's no way around it. So, negative, let's put it decimals, 1 over 3 cubed, negative 3 squared, negative half times negative 1 over 3 plus 2. Maybe it was a better idea to put 1 in there. But we can't change that now. Let's do it. So, negative 0.5 brackets, negative 1 over 3, close brackets, to the power of 3, minus, brackets, minus 1 over 3 squared, minus 0.5, and I know 1 over 3 plus 2 is that 2.07 something something something. I think that's probably part of E. I don't know. I might have checked that. So negative, it's going to be 2.7. So negative 1/3, 2.07 something something something. But is that a maxima or a minima? Well, let's differentiate again. Yep. Negative 3x, negative 2. When I put in negative 1/3, it's going to be 1 minus 2, which is a number which is less than 0. It's negative 1. So therefore, that's a maximum. So there we go. That's all of the questions we use. It's quite a long and involved question, and sure enough, due to prophecy, the took a lot of leg space. I'm just going to pause because I'm just going to check that number. So I did check, and sure enough, the answer is indeed there is a maxima at negative third, 2.07. 4074074, interesting pattern. But that would be the answer. Right, on to question 3. Hopefully my neighbours finished their cooking. A function is given by this. Find the coordinate of the point on the curve where the gradient is equal to 3. So in other words, we want to differentiate it and set it equal to 3. And then solve for x. So 2 times 2 is 4x minus 7, and we're going to set that equal to 3 and then solve for x. So I'm going to add 7 to both sides. 4x equals 10, so x must be equal to 10 over 4, which is 5 over 2, which is 2.5, however you want to do it. Okay, fair enough. Okay, so the geometry question, triangles area is expanding, good, such that the base is always 4 times greater than its perpendicular height. Okay, amazing growing triangle. Find the rate of change of the area of the triangle with respect to its vertical height when the area of the triangle is 98 centimeters squared. So they tell us that the base is always 4 times greater than the height. And we know that the area of a triangle is half the base times the height. So the area is half the base times the height, but we want the area as a function of height. So we know that the base is 4 times the height. So therefore the area as a function of height is going to be half times 4h times h, which is going to be 2h squared. Okay. So then they want us to find the rate of change in the area of the triangle. So they want us to set that equal to 98 and solve for h. Okay. So divide that by 2. So h squared is going to be 49. Oh, that's nice. H is going to be 7. Now it's going to be plus 7. We can't have negative values. David's got his hands out again. So h is 7 centimeters. So we've got a of h. Let's find a prime of h. So a of h is 2h squared. So a dash of h is going to be 4h. And that means that the change in the area with respect to change centimeters is going to be 4 times 7, which is 28. Now, what's the unit going to be? It's going to be change in area over distance. So it's going to be centimeters squared per centimeter. It's an interesting unit, and it's going to cancel to centimeters, I guess. But 28 is going to be our answer, and it's this wacky unit here. But 28 is the main bit we really after. Now we get to the real meat. So, function f of x is defined as that. K is a positive constant. So k is a constant. So k is greater than 0. Using calculus to determine the regions where the function is decreasing. All right, so I'm going to rewrite this. If f of x is that, I'm going to rewrite this as a quarter x to the power of 4 plus k minus 3 over 3 x cubed. This is going to let me use the product, the power rule. 3k over 2 x squared plus k. K is a constant, then these must also be constants. All right, so now when we differentiate this, so 4 times a quarter is 1, so that's going to be x cubed. 3 times this, 3's are going to cancel, so I'm going to be left with 3k minus 3x squared, and bring the 2 out the front, so I'm going to be left with minus 3k x, and then the k disappears because it's constant. Okay, so we want to find the turning points, so we're going to set that equal to 0 and solve. And I can see one solution straight away. These all have x as a factor, so I'm going to factor out the x. And I'm going to be left with So I know that x equals 0 is one of my solutions. Okay, so now I want to factorize this thing that's in the square brackets here. So let's take this x and put it to one side. So I'm just going to be dealing with this. So I'm just going to factorize exactly the same way I would factorize anything else. So I want something that multiplies to give me negative 3k and adds to give me k minus 3. Well, it's just going to be k and minus 3. So we're left with x plus k, x minus 3 as our solution. Okay, run that by you again. So if we had, say, x squared plus bx plus c, we would want to find two things that multiply to give us c and add to give us b. And we do exactly the same thing here. It is k and minus 3, because k times minus 3 is minus 3k, and k plus minus 3 is k minus 3. So we know that x equals 0 is one of our solutions. X plus k equals 0 is one of our solutions. So x equals k, sorry, minus k, and bring the k over, and x equals 3 is one of our solutions. We know k is a positive constant, so therefore, in order, the turning points must be at minus k, minus 1k, 0, and 3. 3 is obviously greater than 0, and k minus 1k is a positive number, so making it negative must make it by definition less than 0. You with me so far? Now, I know that this is either going to look, because it's a cubic, it's either going to look like that or like that. And I can't remember which one is which. So what I'm going to do, I'm going to set k, let's do a really, really huge number, say 10. Okay. So I'm going to set x equals 10. So 10 times 10 plus k times 10 minus 3. That's going to give me 10 times, this is going to be positive. This is going to be positive. That's going to be positive. Positive times positive times positive is positive. So it's going to look like that. So in other words, when we come to draw this, the f dash of x, it's going to cut it at negative k there. It's going to go up, then it's going to come down again at 0, and then it's going to come up again at 3. So f dash of x, f of x must be decreasing from negative infinity, so greater than negative infinity, I know that's not how it goes, to k, and on the interval from 0 to 3, because it's negative here and it's negative here. Everywhere else it's positive, and that's our final answer. Yeah, nice question. So I just realised that I've been solving this a little bit out of order. I've done D before I've done C. So I'm just gonna, no, I'm not gonna get it. This is gonna be the last video. This is the last question. So Evie is designing a lidless rectangular cuboid container for her fishing trip. She just buy a box, such as the one below. The container is made of a maximum of 4.32 meters squared of material. So she's got the wherewithal to build boxes from scratch, but not enough to just go down the supermarket and just get a box. Okay. Pulls to Evie. Evie wants the box's width to be twice its height. So, in other words, the width is going to be 2 times the height. Okay, and she aims to maximize the volume. Find the maximum volume of the box given the limitations above. Prove that the volume is a maximum. Okay, so what we want to find is the volume of this box, and we want that as a variable of one of these things. I'm going to choose H. So my first job is to get rid of the W and the L and do that straight away. There, W and L by exploiting things. Okay, so we want to maximize that, and we want to have it constrained by the fact that the area is equal to 4.32. Okay, so the area, so the underside of the box is L times W. So I'm going to put these in alphabetical order. Plus W times H. Saying that I just broke my rule. H times W, but there's 2 of those. There's one here. And now we want these sides here, and that's going to be LH. And there's 2 of those. So H. All comes after H, doesn't it? Yeah, it does. Okay, and we know that that is 4.32. All right, so let's expand out this bracket and see. So first thing I'm going to do is I'm going to substitute the W in first. So it's going to be L times 2H plus 2 times 2 H, and then in brackets 2H, yes, plus 2HL, and that's going to be equal to 4.32. Okay, we're getting places. We've got rid of the W. So let's get rid of these brackets. So 2HL, this is where keeping it in alphabetical order really helps. So this is going to be 2H squared, so plus 4H squared. Yes. Plus 2HL, we have the same term here, equals 4.32. So 4HL plus 4H squared equals 4.32. Now that's going to be a bit of a mouthful. I wonder if that divides nicely by 4. So 4.9 by 4, 1.08. So that's going to make my life a bit easier. So I'm going to divide everything by 4. So HL plus H squared equals 1.08. Okay, so now that we've got the area in terms of HL, if we isolate the L, we can then substitute that into the volume. We can substitute one formula into the other. We just can't substitute itself into itself because we're going to cancel out get a nonsense answer. We're going to have dogs and cats living together. All hell's going to break loose. So I'm going to take away h squared from both sides. So HL is going to be equal to 1.08 minus h squared, and then I'm going to divide both sides by h. And I'm going to do myself a bit of a favour. So 1.08 over h minus h squared over h is h. So L is that in terms of h. Now we're starting to get places. So the volume is the length, which is 1.08 over h minus h times the width, and we see that the width is 2h. Oh, this is beautiful, and h is of course h. All right, let's do it to it now. So let's get rid of this bracket first. So 2h times h is 2h squared. So 2h squared, 1.08 over h minus h. Now let's break out these brackets here. So 2 times 1.08 is 2.16, yes, 2.16 h squared over h minus 2h cubed over 1.12. Okay, so this is going to cancel, but the h here is going to cancel. The one here is irrelevant. So our answer is therefore going to be our volume is a function of h. It's going to be this then. 2.16 checking minus 2h cubed. So now we have volume in terms of h, and we see that we can differentiate that. So let's differentiate that with respect to h. So we get 2.16 minus 6h squared. Yes. And find the turning point, the minimum maximum, we set that equal to 0. First thing I'm going to do though, I'm going to differentiate that again so we know whether it's a maximum or minimum. This is going to be minus 12h. Okay, but solving this one. So minus 6h squared equals 2.16. So therefore h squared equals 2.16 divided by negative 6. So h is going to be whatever that is. 2.16 divided by negative 6. I know the 6 is redundant. 0.36. 0.36, and I know what the square root of that is. So h squared is that. To the power of 0.5, so I'm taking the square root. 0.6. So when h is 0.6, it's either maximized or minimized. Is this a maxima or minima? Well, negative 12 times negative 0.6 is a negative number. It's less than 0, so therefore it's a maximum. Therefore, the The volume is maximized when h is 0.6. And we have a formula up here for that volume. So the volume at 0.6 is going to be 2.16 times 0.6 minus 2 times 0.6 cubed. Now, cubed bit here, it's just going to make this get smaller and smaller. So, if we grab our calculator, 0.16 times 0.6 is that, minus 2 brackets 0.6 close brackets to the power of 3, we get 0.864. So, right, that can't be right here. So 0.6 to the power of 3 is that, times 2 is that, minus 2.16 times 6. It's going to be a negative number, but negative in the right way. Okay, yeah, that's right. Negative, so it's going to be 0.864. And what's the units? Meters. Meters cubed in volume, and we know that it's a maxima because we just proved it was. And we're done. That is the end of the exam. I didn't really enjoy that exam, but it is what it is. It's a good stepping stone to next year's calculus. Next year's calculus, trust me, you're going to do all sorts of cool stuff. It's off to the moon.
I don't know, man. I swear calculus is just witchcraft for nerds. I swear.